Okay, here we go. Have a look. I'm trying out. Okay, scoot forward if you can. Close up those Chromebooks real quick. I want to go through a couple of practice problems, and then I'll let you work the remainder of the day.
Wait, this isn't for the test.
What's that?
This isn't for the test.
What test?
The fourth, unit 4 test.
This is Unit 5. It's Unit 5. Yeah. If you've got questions on Unit 4, that's fine. I mean, once you get working, you can ask questions on Unit 4 also. That's fine. So what I want to do, let's have a look at this, some questions like this, right? This is from 8.1. These are all from 8.1. They have to do with taking a parent function, and it's stuff like we've done all year. We're going to take a parent function, and we're going to determine how have we tweaked it, right? In this case, the parent function is the function 1 over x. Remember what that looks like. If we take the function, let's call it g of x, equals 1 over x, what does that look like, right? We know that we're going to have a point at the origin where the horizontal and vertical asymptotes intersect, and then normally with this function we would go over 1 and up 1, and backwards 1 and down 1, and then the graph would just look like that, right? It's going to be asymptotic on the x and y axes, and it's going to go through that point, okay? And so we'd say that the coordinates of that point, and remember this is a little bit odd because it's not even a point that's on the graph, but it's the most useful point in graphing the function is knowing where the asymptotes intersect, right? So that's what we're going to call HK, and then we'll calculate A or B like we always would. You know, are we stretching or compressing vertically? Are we reflecting horizontally or vertically, right? So what about this one then? What have we done here? Have we moved we'll call it the vertex. It's not really a vertex, but the place where the asymptotes intersect, which is normally at 0, 0, has it moved?
Yes.
It has?
No.
It hasn't. It's still right there on the origin, right? So we can see that H and K are 0, right? So we know those values right away. H is 0, K is 0, but A has been altered, right? Instead of going over 1 and up 1, we're going over 1 and up how far? 2. So what's A? 2. Because that's how much we've multiplied the amount that we go up. Instead of going up 1, we've multiplied that by 2. We stretched it out by a factor of 2. Right? So A is 2. And then what do we end up getting? So we end up getting f of x equals A, which is 2, times 1 over x minus 0 plus 0. So that's it. It's just 2 times 1 over x. Okay? All we did was stretch vertically. Nothing else.
How?
Because we didn't, that point, we didn't drag. Let's look at another one to compare it to. How about something like that? Now that's different, right? Now the point, this point right here, instead of being at the origin, it's come down, right? We've slid it down how far? 5, right? So is that H or K? K, right? So if we look at the coordinates of this point right here, the coordinates are 0, -5. Well, that's HK. H is 0, K is -5.
So you put 1 over x minus h plus 5?
Yeah, 1 over x minus h, but h is 0. So it's just 1 over x plus -5, so -5, right? What about A? From this point right here, remember, this is that important point. This is the one where the asymptotes cross, right? So that's always where we're going to start off, and then we go normally over 1 and up 1. Well, that's what we did here, isn't it? So A is just 1, right? We don't need to include an A. A is 1, H is 0, K is -5, and so the function just looks like 1 1 over x, right? We don't need an a, we don't need an h, minus 5. All we've done is drop that whole thing down by 5. Okay? How about this one? Now we got more going on. Okay, what are the values of h and k here? Maria, what do you think? So where do the asymptotes cross? Where's that point?
Like 4 and
Good.
negative.
It's going by 2's, isn't it? It's a little bit tricky. So,
Negative 0.5.
well, actually,
Negative
negative 1. See, look, it's kind of, you have to really look at the scales carefully on this. It's going by, every 2 dashes is 1, right? So, yeah, you got this. Right, so this point now has coordinates positive 4, negative 1, so those are my values of h and k. Right, now all we have to do is figure out what's a. Normally we go over 1 and up 1. What are we doing here? We go over 1 and what? Down 1. So what's that, Everett? What's that going to make a? Okay, yeah, those are the coordinates, but we don't care about the coordinates. The coordinates h and k are going to be the coordinates of that point, right? What we care about are how much did we vertically reflect and or stretch or compress the function. Normally we'd go over 1 and up 1, right? But we flipped it. We went down 1, right? So what should a be then? Negative 1, yeah. And just ask yourself, what would I multiply 1 by to get negative 1? Well, negative 1. That's another way to think about it, right? So we know a is negative 1, h is 4, k is negative 1. So what's this one look like then? Well, we just get f of x equals negative, right? I don't put a 1 there, just negative. And then x minus 4, right, because that's h. And then plus k, well k is negative 1, so I'll just put a negative 1 out there at the end, right? That make sense?
Yep.
Okay. What about this one? Last one of these. So what are the coordinates of HK?
3.
3. I even put these little gray lines in to kind of help you find the
Yeah, so you can see it too.
3, 2. Everybody agree? Over 3, up 2. Okay, now what about A? What's A this time?
Up 1, up 1.
Okay, it looks to me like normally we would go up 1 over 1, or over 1 up 1. But we're going over 1 and up how far?
0.5.
0.5, yeah. Okay, so A is 1/2 or 0.5, whatever you want to call it, right? So then we'd end up with f of x equals 1/2 times 1 over x minus 3 plus 2. Right? Everybody agree? Okay.
2.
Okay, so now write a function, right? Is that what we were doing last time? Yeah, it was. Never mind. Oh, okay, no, here's what's different about this one, though. This time, we're not writing the function as a transformation of 1 over x. We're actually going to write it as a rational function, right? We're going to write it as a polynomial divided by a polynomial. So it's the same kind of process. Let's go through the steps here, though. So what are the coordinates of HK? 0, 0, right? Everybody agree? There's HK are at 0, 0. What's A this time?
A lot.
What's A going to be? Yeah, it's a lot. What's it going to be? Emma, what's A going to be? I go over 1. Normally I go up 1. How far am I going up here?
4.
Let's see. I'm going up to 4, right? So instead of just going over 1 and up 1, I'm going all the way up 4, so it's 4 times bigger, right? Does that make sense? This point normally would be there, but it's been stretched up to there instead. Stretched it out by a factor of 4. Right? The point is 4 times as far up as it should be, normally. Right? So A is equal to 4 then, right? So now what? So if we write this down then, we end up with f of x equals 4 times 1 over x plus 0. Right? Okay, but I want to write this in the form, I want to write this as just simplified. So I just get a polynomial on top and a polynomial on the bottom. Well, what would I do? I don't want to write it in the form, we have been writing it in the form a times 1 over x minus h plus k. I don't want to do that anymore. I just want to multiply everything together and write it as a polynomial over a polynomial. So this one's really easy. Yeah, I'm just going to get 4 over 1 times 1 over x is 4 over x. That's my answer. Right? I'm just going to write it as one fraction. Let's do another one. That one's so easy it's almost confusing. Let's try another one. How about this? So this time where's h and k? Tyler, what are the coordinates of hk? 0, 4. Good. So h is 0, k is 4. Good. Mallory, what's a? Well, I'm starting here, right? I always start from the middle point, and I'm going over 1 and up. So.
No, I can't see it, sorry.
Oh no, that's okay. So we're going up 1 because these are going by 2s. Or but yes, I mean that's 1. That's 1/2, and that's up 1, right? So what's a then? Positive 1. Yeah. So a is 1. That doesn't really affect anything, right? So then if we start off, we're going to start off with. Let's put all our phones away, please. I really don't want to see phones out when I'm doing this stuff. So ask once politely. Thank you. So we'll start off with the way we've been doing this, right? We'll use our transformation of 1 over x. A times 1 over x minus h plus k. So what's that give us? A is 1, we don't need that. H is 0, so I just get 1 over x. K is 4. So that's the way we would have written it before, right? But now we want to write that as a single fraction. Well, I'm going to have to add these things up then, right? This is 4 over 1, and that's 1 over x. How do I add up fractions? What do you have to do to add fractions? Common denominator. What's it going to be? I've got an x on the bottom here and a 1 here. What's my common denominator going to be if I've got x's and 1's? No, it's going to be x, isn't it? Right? I'm going to have to get an x here by multiplying by x over x, right? What's that give me? I get 1 over x plus 4x over x, so my denominator is x. What's on the top? Not 5, those aren't like terms. Yeah, it's just 1 plus 4x, right? So I've got my common denominator of x, and on the top I'm just going to get a 1 plus 4x, or how about if we write it as 4x plus 1? So it's written like a polynomial. Right, constant goes last. So that's my answer right there. Okay, one more of those. Okay, well, maybe not. So here's the other kind I want you to look at. So what about this? So this is one where we're going to start off, we're just going to look at the algebra of this time, right? We're going to start off with a rational function that's written in the form p of x over q of x. So I got a polynomial over a polynomial. And we want to write it as a transformation of 1 over x with a's and h's and k's, right? Okay, so how do we do that? Well, all we do is just divide it out. Now I've got my choice. I could just divide it using long division. So let's just go through one of those, right? If the x plus 7 is on the bottom, that's what goes out in front. And then I've got my 4x plus 11 inside. So what is 4x divided by x? No, 4x divided by x. Try that again.
It's 4.
4x over x. Yeah, the x's cancel, right? And so I get 4. The other way I could ask myself that is say, remember when we're doing long division, it's been a while since we've done long division, so you're probably a little rusty on this. We want to know how many times does the leading term outside divide into the leading term inside. So one way of saying that is x times what is 4x? Well, 4, right? So once I get a number out here, I'm just going to distribute it, right? 4 times x is 4x, 4 times 7 is 28, and I'll subtract the whole thing. So my 4x's cancel, and I just end up with 11 minus 28, which is negative 17 in the remainder box, because now x won't divide into that anymore, right? So what did that end up equaling then? So it ended up equaling, how do we interpret this? It equals 4, right, plus the remainder, negative 17. Well, what's the remainder remain over?
X plus 7.
The denominator, right. So that's just x plus 7, right? So if I want to make that look like this form, well, I've essentially done it, right? I just want to flip those around, so the 4 is really the constant. That's k, isn't it? Right? So I'm going to turn that around and write that as negative 17 over x plus 7 plus 4. And so now we can recognize that h is negative 7, right? And k is 4, but what about that negative 17? I want to write it in the form where a is out in front of the whole thing, right? So wouldn't you agree that I could take whatever's in the numerator and I could just factor that out of the fraction? I could just separate the two, and I could write this as negative 17 times 1 over x plus 7 plus 4, right? Because if I were to reverse that, I've really just got a negative 17 over 1, and I multiply straight across, so the negative 17 goes right into the numerator. Right? We're just reversing that thinking, okay? Whatever's in the numerator, we could just pull that out in front of the whole fraction, put a 1 there, right? So then, now we've got it in this form, okay? Let's try another one. So how about one like that? I could just divide it out using long division, or let's this time use synthetic division. Right? Because we can use synthetic division here too. I can use synthetic division because the bottom is in the form x plus a number or x minus a number. Remember, when it is, we can always use synthetic division. Makes life easier, maybe, right? If you're not sure, you can always do long division. But what would this look like as a synthetic division problem? So what number goes in the box? 3, yeah, whatever the 0 of the denominator is, so that's going to be a positive 3. And what are the coefficients? 6 and 7, right? And then I'm just going to figure out that's the remainder box, right? So how do I do synthetic division? What do I do first? Good, I drop the 6 down, then I multiply, right? So I get 18 and I add, and then I end up with 25. So that's the constant, and that's what's in the remainder box, right? So this looks like, once again, if I were to write this out like we did back in chapter, what was that, chapter 6, when we did division, right? When we divided polynomials, we would have gotten 6 plus 25 over x minus 3, right? There's where the 25 goes. Okay, but we want to flip that around and write it in this form now, right? So wouldn't that look like, well, you tell me, what's a going to be? 25. So then there's a 1 on the top. What's x minus h? x minus 3. And then my k is just the constant, right? So now it's in that form. Okay? And so we could graph it if we wanted to, right? Okay, last two, and these are just, there's one little tricky thing here I want you to see. And this is pretty high level stuff. I mean, being able to do this really sets you up for next year. I tell you what, next year is going to be so easy for you guys. It's going to be, it's going to be mostly review of what we did this year, and for if there's a few people who go on to pre-calc, this is the kind of stuff that will make it a lot easier. Okay, pre-calc and trig. So what about this one then? Now, if I want, here's the part that's a little bit tricky about this. If I want to use synthetic division, I can't do it yet because the bottom has to look like the x has to be by itself, and it's not, right? So one thing I could do is I could use long division and not even worry about reducing the fraction. So 4x times what is negative 12x? Negative 3, right? Distribute that through, and I get negative 12x plus 24. Everybody agree? Okay. So I'm going to subtract, and I'm going to get, let's see, those will cancel. Negative 1 minus 24 is negative 25, right? Okay, so what's that tell us then? That tells us that, what is this quotient equal to? Okay, so I get my negative 3 plus negative 25 over what? Okay, so that's fine. So then I could write that as negative 25 times 1 over 4x minus 8 minus 3. Right? That's fine, except what could I do? This doesn't look like, in my final problem down here, that doesn't look like an x minus h. So what could I do on the bottom? Okay, I could factor out a 4, couldn't I? Everybody see that? I could undistribute a 4 from the denominator, which makes that look like negative 25 fourths times 1 over, what's left behind if I undistribute a 4 from the bottom? Okay, 2. There you go. So now we got it. Okay, what's A then? A is weird this time. It's a fraction, right? What is it? Negative 25 fourths. Yeah, it's a fraction. That's all right. It can be a fraction. What's H? 2. What's K? Okay, negative 3. So it all worked out, but look what I could have done. I could have been a little trickier about this. I could have said, all right, let's start with the original fraction up here, and let's just ask ourselves, could I reduce the fraction from the very beginning? And if we do, it makes this whole problem a lot easier for a couple of reasons. I think this last one will do. This is good for today. If I take this original function, f of x equals negative 12x minus 1 over, hang on here, over 4x minus 8. Okay, is there anything I could have factored out at the top or the bottom right from the very beginning?
2.
I could have taken, on the top there's really nothing I could do, right? Because there's no factor of 12 and 1 other than 1. But on the bottom I could have factored out a 4, couldn't I? Right? So do you see then that I could have written this as 1/2 times negative 12x minus 1 over x minus 2, right? Okay, so I've got this 1/2 times whatever we get from this quotient. Okay, this one is a little bit easier to deal with though, because now I could use synthetic division on this one if I want to. Right, I've got an x minus 2 on the bottom. Okay, so Hannah, let's set up this part using synthetic division. I want to take everything in the circle, right? Everything in the bubble, and we want to write that out as a synthetic division problem. So what goes in the bracket? I'm going to divide that out using synthetic division instead of long division. What goes in here? What do we always put in there?
That one number.
That one number, yeah. But I mean, what's,
Up there.
where do we get it in here?
Whatever makes, no.
Okay, go ahead, Mark, whichever makes what?
Whatever makes, I don't know, you plug in something for X and it'll make it 0.
Right, the zero of the denominator,
Zero
right?
denominator.
Okay, let's get everybody's focus up here, please. So what's it gonna be? 2, good. 2 is the zero of the denominator, so 2 goes there. Okay, Nick, what are the coefficients I put in the top row?
Wow.
Negative 12 and negative 1.
Does that make sense?
Have negative.
Right, the coefficients of the numerator, so I get negative 12, negative 1. Okay, now what? Okay, so I'm gonna drop down
Negative 12.
to negative 12. And then when a number appears below the bottom, what do?
Multiple.
Multiply, so negative 12 times 2 is negative 24. Okay, add those up and get what? Negative 25. So look what this gives us then. Now you gotta really be a little bit careful about keeping this organized, because everything we've done with this quotient, right? We did the synthetic division, but that's only the stuff that's inside the brackets then, agreed? So I've still got this 1/2 times whatever we got from the pink bubble, right? So we end up then with 1/2 times that stuff, right? Well, what is that stuff? That stuff is negative 12 plus negative 25 over the remainder x minus 2, right?
Right.
So then all I've got to do is, let's flip that around. Well, actually, let's go ahead and distribute the 1/2. If I distribute the 1/2 through, what's that give us? So it gives me 1/2 times negative 12 is negative 6, right? And then 1/2 times this, well, that's just what that is. That's negative 25 over 2 times x minus 2. But we'll just go ahead and pull the fraction out front, right? So then that's going to be equal to, let's put this term first, and we're going to pull the 25 out of the top and the 2 out of the bottom, which leaves us with what? What's left behind if I undistribute those? What do we get on the top? Joe, what's on the top? Oh, I guess I already just told you. It's a 1, isn't it? I forgot I wrote that. Right, because we're just going to take the numerator out and put a 1 there. What's on the bottom? If I undistribute the 2, what's left on the bottom?
X minus 2.
X minus 2. And then I've got my minus 6, and that's the same thing we should have gotten before. Let's see, what did I do?
You got 4 and 6 instead of 4, or 2 and 6 instead of 4 and 3.
Yeah, what'd I get? How come I got that? 12. What happened up here? Did I do something wrong up here? 4, 3. Oh, I know what I did. Whoops. I took okay, that shouldn't have been a 1/2. What should it have been? Should have been a 4, shouldn't it? Right? Everybody see that? That was my mistake. Right up here.
Silly goose.
Silly goose, I know. Okay, that should have been a 4 instead, which is going to change things a little bit, right? So that means that's going to give me negative 12 over 4 is negative 3. Everybody see that? And then that becomes a 4 on the bottom. So I get negative 25/4, right? So it works. Minus 3. Okay. Which way is easier? I don't know. Maybe you like the long division better. either way. Okay. That's good for today. You can work on those two assignments.